Hello everyone, my name is Tarun. I'm from CSC Department A section. Now I'm going to explain about Prim's algorithm. Let us see why do we need a Prim's algorithm. The Prim's algorithm is used to find minimum cost spanning tree. The main purpose of Prim's algorithm is to find a minimum spanning tree from a given graph. These are the contents that I'm going to explain in this video. First, I will explain about what is a spanning tree and how can we get a spanning tree from a given graph, and then I'm going to explain about a minimum spanning tree. After explaining the spanning tree, it will be very easy to understand what is a minimum spanning tree and how can we get a minimum spanning tree from a given graph, and what are the algorithms that can be used for finding a minimum spanning tree for a given graph. The one of the algorithms that can be used for finding a minimum spanning tree is Prim's algorithm. There is another algorithm also that can be used for finding a minimum spanning tree. That is Kruskal's algorithm. That I'm not going to explain in this video. First, let us see what is a spanning tree. Consider this weighted graph four, which has five vertices and five edges. The five vertices are 1, 2, 3, 4, 5, and it contains the edges which has the weights 1, 2, 3, 4, and 5. And from this graph, we get a spanning tree which looks like this. Let us see what is a spanning tree and what are the rules that has to be followed by a subgraph to be as a spanning tree. A spanning tree can be defined as the subgraph of an undirected connected graph. A spanning tree can be defined as a subgraph. Here, a spanning tree is a subgraph. It contains all the vertices that are there in this graph. The second point says like this: it includes all the vertices along the least possible number of edges. The least possible number of edges, that means number of vertices minus 1. Here the number of vertices are 5 and it should contain 4 number of edges. 1, 2, 3, 4. It contains 4 number of edges. Hence it is a spanning tree. A spanning tree is a subset of a graph that does not have cycles and it also cannot be disconnected. The spanning tree should not contain any cycles. So it has no cycles and it also cannot be disconnected. Here we can see that it is a connected subgraph of this graph. There are two rules that should be followed by a spanning tree. That is, T is a tree. It should be a tree and T contains all the vertices of a graph G. It should contain all the vertices of the graph. Here we have 1, 2, 3, 4, 5 vertices and it should also contain the 5 vertices. As we can see here, it contains all the 5 vertices without skipping anyone. I'm taking the same example. Let us consider this graph which contains V, comma E. That is, V is set of vertices and E is set of edges. And here we have a spanning tree which has V dash vertices and E dash edges, where V dash is the set of vertices of this spanning tree and E dash is the set of edges of this spanning tree. The number of edges for a spanning tree. As I have explained before, the number of edges for a spanning tree is mod V minus 1, where mod V is the number of vertices of a graph. Here we have seen that the number of vertices of this graph is 5. So this spanning tree should contain 4 edges. It contains 4 edges. Mathematically, a spanning tree can be defined as follows. S is subset of G, where S is the spanning tree, and S can be represented as V dash comma E dash, where V dash is the set of vertices of spanning tree and E dash is the set of edges of the spanning tree. And V dash equal to V, as I have explained before, and mod E dash equal to mod v minus 1. Number of edges of a spanning tree is number of vertices of a graph minus 1. Number of spanning trees for a given graph. So to know how many number of spanning trees that can be formed for a given graph, we have a formula which goes like this: mod E C mod V minus 1 minus number of cycles. Let us apply this formula for this spanning tree for this graph. Mod E, that means number of edges 5. 5 C mod V minus 1. Mod V is number of vertices. We have 5 vertices. So 5C4 minus number of cycles. We have 0 cycles. So minus 0. 5C4. What is 5C4? It is 5, right? So we can form 5 number of spanning trees from this given graph. Hence, we can use this formula for finding a spanning tree for any graph given. So here I have taken an example. From this example, these many number of spanning trees can be formed. Let me explain about a minimum spanning tree. A minimum spanning tree can be defined as a spanning tree in which the sum of the weights of the edge is minimum. What is a weight? A weight is a number that is assigned to each and every edge of a graph. What is a cost? The sum of the weights of a graph. The sum of the weights of all the edges of a given graph can be considered as a cost of that graph. The cost should be minimum for a spanning tree. If the cost is minimum for a spanning tree among all the spanning trees, then that spanning tree can be considered as a minimum cost spanning tree or minimal spanning tree. Consider this following example, which is a weighted graph. As we can see here, there are 2, 3, 5, 6 weights are given to each edge of this graph. It contains 4 vertices A, B, C, and D, and 4 edges whose weights are 2, 3, 5, 6. You can get these many number of spanning trees from this graph. From these 4 graphs, as we can see here, each spanning tree has different cost. Here we can see the cost of this spanning tree is 8 plus 6, which is 14. And the cost of this spanning tree is 11. And the cost of this spanning tree is 13. And the cost of this spanning tree is 10. Among these 4 spanning trees, the cost of this spanning tree is low. Hence, we can say that this is a minimum spanning tree. Among the above spanning trees, spanning tree 4 can be considered as a minimum spanning tree. Means because it contains the cost 10, which is lowest among these 4 spanning trees. Hence, it is a minimum spanning tree. So let me explain about Prim's algorithm. There are 2 algorithms that can be used for finding a minimum spanning tree for a given graph. There are 2 algorithms that are Prim's and Kruskal's algorithm. I'm going to explain about Prim's algorithm in this video. As I said earlier, the main purpose of using Prim's algorithm is to find minimum spanning tree in a greedy way. These are greedy methods. Prim's algorithm and Kruskal's algorithm are considered as a greedy methods to find the minimum spanning tree. By using these algorithms, we can find easily the spanning trees can be found. The minimum spanning trees can be found easily. Steps to find the minimum spanning tree using Prim's algorithm. These are the steps that has to be followed to find a minimum spanning tree using Prim's algorithm. There are other steps for Kruskal's algorithm. First, we have to select the minimum cost edge from the given graph, and then always select the minimum cost edge from the given graph, but make sure that the edge should be connected to already selected vertices. I'm going to explain these steps by taking an example. Consider this example graph, which is a weighted graph. It contains four vertices and four edges. We are going to find a minimum spanning tree for this given graph using Prim's algorithm. The weights of the edges are 2, 3, and 5 and 6. It contains the vertices A, B, C, D. First, we have to take the edge which has minimum weight. As we can see here, the edge which has the minimum weight is BD, which has only 2 weight. So first we have to take BD as first edge, and then we have to take CD, because as we can see here, the second point explains that, and then always select the minimum cost edge from the given graph. Make sure that the edge should be connected to already selected vertices. We have selected BC vertices, and the CD, which is a edge that we are going to select afterwards, is connected to D. Hence, we can select this CD edge, and also the 3, which is less than 5 and 6, right? So we have to select this CD edge. Hence, I have selected CD edge, and then next, what we have to select? We have among 5 and 6, which is the lowest one, 5, right? And hence, it should be connected to already selected vertices. Already selected vertices are B and D. AB is connected to B vertex. B vertex is there in AB edge. So we can take AB as our next edge. Hence, I have taken this. Now we have taken AB as our last edge. Why shouldn't we take AC next? Because AC is edge here, but if we take AC as our last edge, then it forms a cycle. A tree should not contain a cycle. That is the condition that a tree has. If it has a cycle, then it is not a tree. Hence, we should avoid this AC edge. And also, if we take AC edge, then the number of edges are 1, 2, 3, 4. 1, 2, 3, 4. 4 edges shouldn't be there, because we should only have 3 edges. As I have said earlier, mod V minus 1 number of edges, where mod V is number of vertices of the graph. Here we have 4 number of vertices. So we should have 3 number of edges for this spanning tree. Hence we have 3 number of edges for this minimum spanning tree. And I got this minimum spanning tree by using Prim's algorithm. Like this, we can use Prim's algorithm to easily find a minimum spanning tree from a given weighted graph. The minimum spanning tree can only be found for a given weighted graph. Unweighted graphs don't have minimum spanning trees. Let me quickly recap what I have explained in this video. First, I have explained what is a spanning tree and how can we find a spanning tree from a given graph, and what is a spanning tree. The exact definition I have explained. It is a subgraph of a spanning tree. It should contain all the vertices, and it should contain n minus 1 number of edges, where n is the number of vertices of the graph. And then I have explained what are the rules that has to be followed by a subgraph that needs to be a spanning tree. These are the 2 rules. The T should be a tree, and T contains all the vertices of a graph G. And then I have taken an example and I have explained how many number of vertices a spanning tree should have and how many number of edges a spanning tree should be have. And then the mathematical representation of a spanning tree is defined as follows. S is a subset of G, where S is spanning tree and G is a graph. The spanning tree has V dash number of vertices, V dash set of vertices, and E dash set of edges. The formula that can be used to find the number of spanning trees for a given graph. This is the formula mod E C mod V minus 1 minus number of cycles. I have taken this example and I have applied that example in this formula and we got the answer 5. 5 number of spanning trees that can be drawn from this graph. And then after explaining spanning tree, I have explained what is the minimum spanning tree. Among these 4 spanning trees that has been drawn from this weighted graph, the spanning tree 4 is a minimum spanning tree because it has the lowest cost among the 4 spanning trees, which is 10. It has 10 cost, which can be seen here 5 plus 2 plus 3. And I have explained what is the Prim's algorithm and what is the main purpose of Prim's algorithm to find minimum spanning tree and what are the steps that needs to be taken in Prim's algorithm to find a minimum spanning tree. These are the 2 steps. And then I have explained the Prim's algorithm how to find a minimum spanning tree from a given weighted graph by using these 2 steps. And we got this minimum spanning tree from this weighted graph. And yeah, that's it. Thanks for watching. Thank you.